Today's topic is simplifying expressions. It's the part 2 of our algebraic expressions topic. So let's go take a look on how we would simplify expressions. Like terms. Well, what are like terms? We talked about what terms were in our first video, meaning terms were separated by plus or minus signs. Well, like terms are terms that have the same variable raised to the same power. So whatever variable's there, its exponent basically has to be the same. So let's look at some like terms. You have 4x, 3x, negative 8x, and x. Each one of those has an x in them, and all the x's have an exponent of 1. So they're like terms. Now here you see each one of these has an xy squared. Therefore, those are like terms because the x in each one is raised to a power of 1 and the y is raised to the power of 2. And each one has an xy squared. They have to have both variables. Then finally, what a lot of people overlook is the constants. Those are like terms. Those are numbers. Well, what is an unlike term? Or a non-like term, I should say. Well, look, if you look at each one of these, yes, the coefficients of them are all 4. The number parts are the same, but the variable is different. So when we talk about like terms, we want the variable, the letter, to be the same. Here, it almost looks like it is. Each one of them has an x and a y. That's great. But the 8xy squared has a z with it. Right away, that throws it out. And then on the 12xy squared and the 7x squared y, the exponent is on different variables. So none of those are like terms. And then finally, these are not like terms. Okay, so why do we need to be able to identify like terms? What's the point? Well, like terms are needed when adding and or subtracting. So in order to simplify an expression, and when we say simplify, you're going to see this word a lot throughout math. It means to take your problem and go as low as you possibly can go. So when we are simplifying, we look at the coefficients and add or subtract them, but the variable is going to stay the same. So combining like terms, that's why. We're going to combine them in order to simplify. We want to get each like term down to one of each type. Then our expression is completely simplified. Okay, so how does this work? Well, let's take a look. If I have 12xy squared plus 7xy squared, both of those have xy squared. They are like terms. So just like we said, I'm going to add just the coefficients. I'm just going to take those two numbers, but leave the variable the same. So really, this is 19xy squared. Okay, let's look here. So I have an x cubed minus 9x cubed. So the way I look at this is I have one in the front and one in the back. Now I'm subtracting them. But how many x cubes are there? Well, we don't see it, okay? There's an imaginary one there. So the way I look at this, treat your variable as a product. So x cubed, I don't know, think of it as an apple. I have one apple minus 9 apples, or think of it as money, okay? I have $1, but I owe someone $9. So we're gonna focus on just the number part. Okay, so 1 minus 9. Well, when I do that, I'm still down 8. I'm negative 8. Remember, the minus sign goes to the term behind it, and it makes it a negative. So just focus on those numbers. Okay, so this is going to come back in, I believe it's topic 4, the associative and the commutative property. We're going to go into detail about what that looks like. And you've been using it since elementary school. You just haven't realized it. So these two properties together allow us to move these around and multiply easily, meaning I can break apart. This all means multiplication. Okay, when I don't see a symbol and they're all next to each other, I'm multiplying. But what I can do is I can put my numbers together and my variables together to get negative 21ab. Okay, that is simplifying that expression. I have gotten it down to one term. Notice I can do this because it's multiplication. It's not addition or subtraction. Okay, so here's the commutative property in detail. Again, I can move the terms around and then put them next to each other. So a little different than the one before, but I'm going to move my 4x that I have here and my 2y. So now they're grouped together. Now I can add and subtract what's alike. 3x plus 4x gives me 7x. 2y minus 9y gives me negative 7y. And then 2 plus 5 gives me 7. I have now officially combined all these terms. There's my answer. Okay, kind of straightforward, but I wanted to throw a little bit in there for you because if you look at the original problem, it's 1/3 x squared y squared. All I want to know is what are like terms, okay? Remember, what are we looking at for like terms? We're looking at the variable raised to the same exponent. So take a minute, pause it, and try and answer this one. Okay, so let's see how you did. While the order is different, this is still multiplication. It's got the same variables raised to the same exponent. I can rewrite that, and that's why I showed you the associative property and the commutative property. And then we have 7x squared y squared. Okay? So now it's your turn. Take a moment, pause, and simplify these expressions. Remember what it means to simplify. The way I think of it is go until you can't go anymore. Just get them down to one of each type. Okay, let's see how you did. So if we take a look at our first one, 4a plus 3a, you should have 7a. When I go over, okay, first we need to rearrange them so that I have my like terms next to each other. It just makes things a little easier to group. You don't have to do that. But when you do, you get x plus 4y plus 16. These last two should be a little easier. All I'm doing is multiplying. You should just have negative xy squared, z, sorry. Now I'm going to let you know if you put a negative 1 in front, that's still okay. But if it was multiple choice, you would not see that 1 there. So get used to writing it without the 1. But know a 1 is in front of it. And last but not least, if we regroup this and we put our numbers with our numbers and our variables together, I should get 20 GR. Getting the hang of it? Okay, so let's look here. This is, again, just expressions. An airplane is flying at 35,000 feet above sea level. The airplane starts to descend at a rate of 2,500 feet per minute. M is the number of minutes. They've already done our let statement for us. Which of the following expressions describes the height of the airplane after any given number of minutes? Well, let's just first start and look at everything. We know M is the number of minutes, okay? And what else do we know in this problem? Well, it's 2,500 feet per minute. Again, when you see that per or each, that's going to signal the multiplication for you, okay? We also know it's descending. Well, in math, this is where I said keep that one page of notes and add to it Descend means to subtract. So right away, I'm going to look where my two subtraction expressions are. Those two, okay, I'm between one of those two, meaning I can cross out B and D. They're not going to work. They're not, those are addition. So then I need to go back and look at what else is in my problem. Well, it said that it's starting out at 35,000 feet. That's where the plane is flying. That's our originating starting point. So if I'm starting from there and then descending, okay, that makes it a little easier. This one starts at 2,500, but we just said that that 2,500 was the per. That's what we're multiplying. So here it's 35,000, and that's what it's starting at. So that should signal to you that C is in fact your answer. Okay? These concepts aren't going to go away. Take the strategies we're giving you here and apply them throughout the rest of the school year and this section. Okay, so here's our last one. Ashley posts 17 status updates on her Facebook wall each day. All right. Roberto posts 21 status updates on his Facebook wall each day. So part A asks us to define each variable and write an expression to describe the combined number of posts for Ashley and Roberto after any given number of days. Okay, and we'll get to part B in a minute, but let's go back to part A. Well, in our original problem, we see these words, each day. That's that kind of trigger word like the per, okay? Well, each is repetition, so it's going to be the same amount each day. This should start signaling to you that we're going to be multiplying. But we have to define a variable. What don't we know? What do we change possibly? Okay, and that tells us in part A, we're coming up with an expression for any given number of days. Meaning I can figure out how many they post after 5 days, or I can change it to 12 days or 30 days. So right now my unknown is my number of days. Okay, so D equals number of days. Well, let's go back. Ashley would be 17D, because she's doing 17 for each day. Roberto would be 21D. Now this problem asked for an expression. What would the expression be to describe the combined number of posts? Well, combine tells me to add. There's another key word. So this would be your expression, right? 17D plus 21D. That is an expression to describe the combined number of posts. But what if I wanted to simplify that? Are those like terms? They are. The reason we would simplify it is because it's much easier to plug in any given number of days to D and multiply it by 38 once versus using our first expression, okay? So let's go down now to part B. If I wanted to write an algebraic expression to describe the difference between number of posts for Ashley and Roberto after any given number of days. Go back. Write an algebraic expression to describe the difference between. So what does difference mean? Difference means to subtract. If you go back, Ashley's 17D, Roberto's 21D. Could I have a negative amount of posts if I just did Ashley minus Roberto? No, I can't. So since this is not an order situation, you want to know just how far apart are those two numbers. So you're going to subtract them, but you're going to put Roberto first. Okay? When you combine that, you should get 4D. So there's a lot of things that we went through over the past 2 videos. By all means, feel free to go back, rewatch, pause the problem on your own, and see if that makes sense to you and try it without our help. But this is just the tip of the iceberg, but everything we did in these two sections are going to be applied throughout the entire school year.